There's something so terrifying, so mind-bogglingly horrifying, that they can only come from one place: calculus class. So, tonight, we depict for your didactic enjoyment an epic battle between calculus students like yourselves and a polynomial integral. That's in this episode of
Hail from the Calculator.
Dun dun dun. So, we begin. And listen closely or I'll steal your batteries out of your calculator. So, on one dark and stormy autumn morning, some students were turning in their calculus homework. There you go.
Good work, Stephanie. I wonder why you're getting the best grade in the class.
Thank you.
Doesn't look correct, Nicole. You're gonna have to give more effort. Emily, how many times have I told you not to use pen on your homework? And this is filled with mistakes. The antiderivative of x cubed is not 3x squared. That's the derivative.
There's a difference?
Of course there's a difference. If you've angered the calculus gods, you'll incur their wrath by misusing the rules.
I don't believe in the calculus god. That's just something you made up to scare us.
Don't be so sure of yourself, Emily. Calculus teachers know the secret of the universe. I bet the gods will be planning destruction as we speak by misusing the rules.
Emily, do you think the calculus gods are going to spite you like Mr. D said?
I don't think so. I really don't believe in the calculus gods.
I don't know. You seem pretty confident that they don't exist, but I believe in the calculus gods. I think you should be more careful.
Stephanie? Oh my! It's a calculus monster!
Oh no, it's the calculus monster! I think it wants you to solve the equation.
Really? What should we do? Well, maybe, why don't we do what we always do? I'm just going to run away from my calculus work.
Good idea!
Run from the calculus monster! Oh no, the calculus monster chased us down into his lair! Look, it's in.
So this is how we find the general antiderivative of x squared plus 3x plus 2. So, we start out with the equation in this form, like the integral sign out front and the dx in back, and we take up the power on each of the terms. So the first one becomes x to the third, but we have to put it over 3 because x squared doesn't have a coefficient in front of it. So if we took the derivative of this, we would take the power down 1 and make it x squared, but then the 3's would divide out. Plus the next term, which also comes up a power, so that makes it x squared. But we have to take into consideration that this does have a coefficient in front of it, so this becomes 3x squared over 2. So if we took the derivative of this, the 2's would cancel out and it would become 3x. Plus 2x, this one's pretty easy, just add an x, plus c. So c is a constant, and we don't know what it is yet. We would need a point to find. To plug in here a y and an x to find c. And that's it. We found our general antiderivative of the equation.
Where did that C come from? I don't know what C is. That's right. We need to discover what C is. That's what the calculus guys are telling me.
How do you always know what these calculus gods tell you to do?
Because I spent so much time studying. I'm in tune with the calculus forces. You know, because of computer club.
Can you use this force to get rid of the calculus monster?
I guess. At least temporarily.
We'll do it. Hey, Stephanie! The monster's gone!
Let's go find C before it comes back!
The integral of y dy? What's this? Is it helpful?
I don't think so.
I don't even know what this is.
We'll probably learn that in a later chapter.
I seem to remember this. Is it helpful? Maybe.
Oh no, more equations! Save us from the calculus gods!
Natural logs? I don't even want to mess with those.
Yeah.
Oh no! It's Trig!
Oh no!
Nah. Hey Stephanie, what is this?
I don't know. I was probably absent for that.
Hey, I know this one. Oh, I forgot limits. 0?
5? There must be a point! Now we can find C! Okay, so now that you have your general equation and your initial conditions, the points 0, 5, you can plug in your points 0, 5 into your equation to find what C is. So you plug in 5 for y and 0 in for x, and you get 5 equals 0 cubed over 3 plus 3 times 0 squared over 2 plus 2 times 0 plus c. And you simplify this to get 5 equals 0 plus c, and you solve for c and you find that it is 5. So now that you have found your c, you can plug that into the original equation and you get y equals x cubed over 3 plus 3x squared over 2 plus 2x plus 5. And now you have found your equation with the initial condition, the point 0, 5. Yay!
You can't get us, calculus monster! We know what C is! Yeah, C is 5! Ha! Yippee! We beat the calculus monster!
That's great! But, how do we get out of this creepy basement?
Oh, yeah. Okay.
Wow. You know, as crazy as that calculus experience was, I think it really helped my brain.
Yeah, the grades have really improved. You must be studying a lot more now. And with computer club, you know. Cool.
Oh well. And so, our little misadventure with integrals comes to a close. So next time when the fog drifts through the air and the werewolves howl in the distance, make sure you curl up by a nice fire and do some calculus problems. Otherwise, the calculus god might get you. So, tune in next week for episode 90 of Tales from the Calculator, The Limit Side of Limits. Thank you very much.